just overall how you should act at competition. Overall, like how you should act at competitions, what you need to do, and just stuff like that. So let's go ahead and get into it. So who am I? My name is Carter Stevens. I'm a former Vex competitor. I just graduated this year after Spin Up. I was on team 99067B from Change Up, which was the game in 2021, to Spin Up, which just ended this season. So some accomplishments I did in my Vex career. We won our division at Worlds this year, which was pretty cool. It was nice to win a division finally, after unfortunately losing in round of 16 tipping point, but that's besides the point. And then we won states 2 years in a row for Arizona, tipping point, and spin up. And I'm a freshman at Arizona State University. And I'm currently majoring in mechanical engineering, though I think aerospace is calling my name. Gonna switch soon. We'll see how that goes. And I pop back and forth in competitions. I help out, volunteer. And maybe this season you'll see me doing some judging stuff. But that's who I am. So let's go ahead and start the competition best practices. So before we start, we're going to look at the agenda for this slideshow. So we're going to talk about before the event, how you should act, what you need before the event, because it's crucial to ensure success at competitions. During the event, how you should go to certain teams, ask them about the robots, do some scouting, um, managing your time, match strategy, and then after the event, how you should try to network with other teams, get their Discord, and share resources to improve for future competitions, scouting, data collection, and using data for your pick list. And then we'll also be talking about some driving tips. So let's go ahead and start. So before the event, obviously, you need to have your equipment laid out. You need to make sure that you have all your parts necessary. So like I know when I was packing for events, or Miss Harden and I, we would look at all of our C channels, make sure we have extra metal, extra wheels, extra gears, just in case something bad happens at the event, like for instance, like a low strength gear snapping. Always want to make sure you have extra supplies. And also, you need extra game elements because that's very important because sometimes the practice fields get way too cluttered. So you need these extra game elements to practice at your pits. And make sure you label your equipment because you don't want anything getting mixed up with other team stuff because sometimes the pits are super close to each other, super uh, jammed packed. So you don't really want your stuff getting stolen accidentally by other teams. So just make sure all your parts and such are labeled with your team number. And then lastly, another really important thing that I think a lot of teams undermine is lunch. You need to be properly energized during these competitions, or else you'll feel horrible. I remember the first competition for spin up at Mountain Point. I didn't eat anything the entire day. So when the elimination matches started, I was like super fatigued, super tired, and we ended up losing because I just wasn't at my best performance. So you always need to make sure you know what you're doing for lunch and transportation there and back. Super important for competitions. It's something a lot of teams look over. And also, you need to come up with hypothetical scenarios prior to the event of what you want to do or what could potentially go wrong. So, like, if, for example, you want to be ready for the worst, essentially, because if your autonomouses don't work, you want to understand why you didn't achieve your like goals at the event. So, like, let's say you have a goal of ensuring that the autonomouses that you've coded work properly. You want to understand potentially why those autonomous might have not have worked at the competition, just so you aren't disappointed and being like, what's happening. And you kind of want to minimize these errors at competitions because you don't want like these autonomouses to not work, and then you're at the competition saying like, how could we have prevented this? Because sometimes fields varies and stuff like that. So set like I guess at competitions you should really expect the worst, which sounds super bad, but if you expect the worst, you can kind of minimize error in that sense. So now we're going to look at pits. At most competitions, it's generally just a really small table that you can put all your stuff on. And make sure you have like your essential parts there for maintenance and repairs. Like after matches, let's say like a C channel gets bent on the back of your robot, you can easily find your stuff, which also goes back to the point of labeling your parts. Because if none of the parts are labeled, you won't know what's what, and then you waste time potentially missing another match. And always have like one dedicated person as the pit boss on your team. So I know we did this last year. We would make sure that they're always at the pits, making sure everything is smooth and nothing is like lost or damaged. Because as we said earlier, the pits are generally pretty small and pretty jam packed, so you don't want to get anything confused with other people's stuff. Always have water and snacks, and try to keep the pits as like little people in them as possible. Because of the size of like how small those tables are, you don't want anyone to like, or we don't want your entire team going in because it's just super cluttered. I know at Worlds we were like a 6-person team. So with the size of the world's pits, when everyone was back there, it was just super clustered and just stressed people out. But always make sure to have like someone at your pits all of the time. So just to make sure like nothing gets stolen and you have all your parts there. Batteries. Okay, this is super important because I know sometimes we get so caught in the zone we don't realize that, oh crap, our battery is at like 30%. Just always make sure you have batteries charging at your pits, and you should always have someone who's dedicated like with batteries. So like we did this at Worlds and all of our competitions. We'd have one person carry 2 extra batteries in their pockets just in case we forget to change it before a match, and they'll always ask us like, "Hey, what's our battery at? Do we need new batteries? Should I go plug this in?" It's just super important to always have batteries like charged, just because you don't want your robot like dying right before a match, and it's like, "Oh well, we had to start without you." Because that would be super unfortunate to not be able to play a match just because you weren't ready, and it's just your fault. So just make sure you always have extra batteries on hand and ready, just in case. Just in case. So tournament rules. There's a lot of people on the team, so you always want to dish out your roles according to what they would like to do. So there's a mechanic, just someone who's like repairing the robot and builds it. Make sure that if something bad goes wrong with the robot mechanically, you can kind of fix that at the competition to make sure stuff works. The programmer, a scout, a strategist, a battery specialist, so the person who just carries the battery back and forth. The pit boss, someone who's always at the pit. The driver, drive coach. So even though these 8 roles, a lot of people will oftentimes have 2 or 3 of the roles. Like for example, the scout and the strategist will probably be the same person, and the driver needs someone to like help them because sometimes you get so tunnel vision when driving, so you just need someone to be like, hey, you need to do this because you're not really focusing on like other people on the playing field. And then like the pit boss and the battery specialist also might be the same person. So just keep in mind, like you don't need 8 people on the team to carry out each role. Rather, people on the team will have multiple roles. Okay, so now let's talk about before the match. So what you should do, or well, at least some tips that I could give, is before every match, you should always talk to your alliance partner. You need to figure out who they are, what their robot is capable of, what they can do, autonomous is, and overall just see if they are capable of scoring or should they be a primarily defensive robot. This is super important because if you have like if you design your robot for defense and then someone else's, like your alliance partner, for example, is also a defensive robot, you don't want to just go into the strategy of, okay, we'll both play defense, because you'll just lose because you can't. It's hard to score points if both of your guys are just playing defense. So you always want to split it up to where one person's the offensive robot and one person's the defensive robot. But the strategist should also gather information and crucial data from the other scouts, and the drive team and strategist needs to develop a plan based on everyone's abilities. So as I just said, like just one person should always probably be doing offense while the other alliance partners primarily focus on defense. And always have backup plans, because sometimes in your head, this plan, like a plan during a match, could be perfect. Though you could encounter like, our drive motors were overheated. We're not able to move properly. And then you need to have that very good communication with your alliance partner to tell them, hey, our drive is overheated. It's not working. Stuff like that. Okay, so now, and always complete a pre-match checklist before you start your matches. Okay, so during the match, the drivers will drive, and the drive coach will watch what they're doing on the field. This is important because the drive coach should always keep an eye on the clock and telling them, hey, we have 30 seconds left in the match, or we have 40 seconds left in the match. This is important because as a driver, I know myself, I wasn't focused on the time at all. I was just focused primarily on what my robot is doing and only my robot. So the drive coach should also clearly communicate with your alliance partner. This is super important at higher level events where you're making split second decisions time and time. So if you have a good drive coach who's properly communicating with your alliance partner, your chances of winning a match like exponentially go up, just because of those split second decisions in your drive coach looking over, telling them, hey, we did this, you need to go play defense, or vice versa. So if you're not on the drive team, you can't give any directions. Like you can't be in the crowd and being like, "Oh, there's 20 seconds left," or "You need to like you're down 5 discs." Don't do that. It's not allowed. Don't be that guy. Um, and yeah, matches do go by super fast when you're driving a robot. Like it doesn't feel like a minute 45, but it goes by quick. So always keep that in mind. You don't have that much time to win a match, so make the most of your time and just be sure to practice beforehand. And if you win, like always make sure you know you win auto because this is super important. I know it happened at States this year in finals match where a team looks like that they've won, but because of the autonomous period, especially in the spin up game, that 10 points makes a huge difference. So just if you win the autonomous period, keep that in the back of your mind, even if it looks like you didn't win the match, because you never know. And then after the match, make sure you yourself consciously look at the field, be like, okay, we scored X amount of points. We have this many discs in the high goal and such and such. And always confirm the score of the scorekeeper because sometimes as humans, we all mess up. We all make little mistakes. So just keep in mind that the scorekeepers might mess up the score. So don't like yell at them or anything. And just confirm the score after you check it. And then if there is a potential rule violation, have one person on the drive team go up to the head ref. Don't send the entire team. I'm sure it's super annoying for them to have 5 people come to them and be like, they did this, they did this, they did that. Just have one person go up. It makes their life a whole lot easier. And it's just being a good person. Yeah. And then after the field is reset, the scores are final. So once that's done, it's done. You can't go back up to the head ref and be like, wait, you didn't do this. Well, you should have told them before. The score is final. And then I know in spin up this was a huge problem, but be ready to untangle your robot. Last year, all the string shooting was just total chaos. But even in like other games, sometimes your robot might get wedged under like a drivetrain or something or an intake. So just be careful to make sure nothing breaks, and just be ready to take off another person's robot if it's like entangled in yours by accident. So skills is super important. Don't make the mistake of waiting for the last 10 minutes of the competition to do your skills runs. Skills runs can qualify you for the state championship or even the world championship, depending on your score. Get your runs in early. Don't do the thing of waiting. It's bad. You'll only get one in, and then you're gonna get yelled at. It's not fun. Yeah. So just get your save points first. So like, if you know you have a high autonomous routine, and you know you have a chance of potentially winning skills, just make sure you run it first. Get those points in just in case, because other people's autonomouses for skills might not work, or their driver skills might not be as good that day, and you could win skills just because you got it in early. And if you do plan on doing a skills stop time, make sure you inform the scorekeeper referee. Be like, hey, we're gonna plan on stopping at 10 seconds, just so they know. Don't be like, wait, stop mid run. It just makes their life a whole lot easier. So just make sure you do skills. It's super important. I know it states there were some teams who didn't do skills. You can qualify for like to worlds from it, like if there's double qualification. So doing skills is like a good backup just in case, you know. So scouting. Okay, this is super important at competitions, and even before competitions, you can do this. Looking at a team's past competition, seeing how much points they score, and so forth. It's a huge advantage, especially when it comes to line selection and match strategy, because if you know what a team is capable of prior to actually going up and talking to them, you kind of have a better sense of like how the match will play out, just giving you a more direct line of strategy. So you can also walk around pits, which is called pit scouting, to go look at robots. Be like, okay, this robot looks pretty offensively capable, or this robot looks like it can do defense and stuff like that. And then match scouting, so we look at the team's points, OPR, DPR, contribution to winning matches, autonomous wins points. That can be used to collect data on like that robot's specific performance. So a smaller team means less rigorous scouting because you just have to go up to like one person and be like, hey, what does this robot do? And stuff like that. But another good resource for scouting is networking. Because if you know like good teams prior to going to a competition, like just because of they're so well known, it gives you a kind of an upper hand of what to expect at a competition. Because you're not going to be totally shocked when like there's this one team who's just like destroying everyone. So if you like do pre-match scouting, like look at the team list, see who you're gonna face up against, check how well they've done at previous competitions and stuff like that. So pit scouting. This is super useful, especially in the early stages of a competition, because you can just walk around the pits, look at other teams' robots, and be like, hey, ask the people on their team, what can your robot do? What is it capable of? Can you shoot? stuff like that. Are you good at playing defense? Do you have an autonomous? Ask him about their drive motors, because I know in the previous Vex games, 6-motor drive has been like a huge meta. So if you look around, be like, are you 6-motor drive? Are you a 4-motor drive? Because in games where you play heavy defense, if you have that information of being like, hey, this team's a 4-motor drive, you play defense on them the entire time, they won't really be able to do anything about it, especially if you're a 6-motor drive. And you can kind of just check a team's build quality based off of walking around their pits and looking at it. Um, and if it comes to the point where you're super shocked and surprised by like how good this team is, their robot looks beautiful, they're super good, ask for a picture of the robot, but always ask before you do this. Don't go up to a random team to start taking photos of their robot. It's pretty rude, and a lot of teams don't want you to publicly post their robot places. So always ask before you do stuff like that, because they might want to keep a certain mechanism on their robot private. So now we're going to talk about match scouting. So you can gather information that you cannot gather from the score, like the number of game objects scored and the number of game objects descored. You can also go up and ask them about like their autonomous routines, how many do they have, what do they accomplish, and you can look at was defense played on them, how well do they play up against defense. Like some teams at Worlds might have been like super good at offense, but when a team just does a little pushy, their scores go way down, and they might not be as good when teams play defense on them. You always want to point out it's crucial to see do the alliance that you're going against have a weakness, because if you know that weakness, you can exploit it, allowing you to win a match. So like the pushy defense one, or if they can only score from one spot, you want to take advantage of that, because they won't be able to score, causing their score to go down, and the chances of you winning the match being significantly higher. So match scouting. So what we did is we would make Google Sheets, and we also did paper, but you can do electronic or paper scouting. Either or works. It just the electronic scouting makes stuff totally easier, because you can just like already have a form made prior to attending the competition, just fill it out as you go. But do be aware that the sample sizes are small. So even if a team's looking good for like 2 matches, that might not be the case for the rest of the tournament. So just always be aware of what you're trying to accomplish at a tournament, and just always ask the team, and just if you want to potentially alliance or stuff like that, just watch all their matches, because it might be a fluke if they're only doing good for like 2 games. So the scouting assignments. So the scouting system is often created by the team strategist or scouter. Um, Normally, when you do pit scouting, or what we did was we would have one person or 2 people walk around. Normally, I would walk around the pits and ask teams about their robots and be like, hey, what does this do? Are you guys good at offense? What autonomous routines do you have? Can you guys play defense? Stuff like that. But there should be one person always asking your alliance partners before every match, what can it do? Do you have an autonomous? What does your autonomous do? Can you get the autonomous win point? Stuff like that. But do be sure to swap out like your strategist and have other people do it, just because it's good for that person to get a little break from doing scouting. And if you don't have that many people on your team, just kind of reduce the amount of teams you scout. Maybe make a list of teams you know who might be scary at the competition, seem really good. Go up to them, talk to them, like what does your robot do and stuff like that, just to gather that crucial information on the teams who look good and could potentially win the tournament. So data for match planning. So the strategist should always give the data to the drive team, because that information will be crucial for the drive coach to look over and be like, this robot plays defense, this one's good at offense. It's just really good for the scouter and the drive coach to have really good communication with each other, just in case like you're like, who's this team? Because the drive coach might not know, and the strategist comes to be like, oh, they can do this, they can score that at many points, or they have this autonomous. It's just really nice to know who you're going up against in detail before you're actually playing against them. And then you also want to make sure that the methods of scoring, like you and your alliance partner, doesn't like have a problem with each other. You don't want 2 offensive robots, or well, you might, but depending on your match strategy, if you have this strategy, like no, we want to score discs the entire time, you can't do that. You don't want to have that conflict mid-match, because it'll just create problems between you and your alliance partner. And you always want to capitalize on the weak points of the people you're playing against. Like if you know they can only shoot from one spot, or they're only good at doing offense, you want to take advantage of that and push them around, take advantage of that spot where they can only shoot and stuff like that. And You also want to be sure, like, if there's a team you're aligned with, this was a problem last year, like shooting string outside the field. You want to be aware that that team is kind of violating the rules, and you don't want to get into a situation with the head ref. It's just a bad. Just so be aware if your alliance partner does tend to receive penalties. It's pretty important to know just for like alliance selection in the future. So making a pick list. This is super important for tournaments because this is who you're going to be playing with for the actual like the actual single elimination part of the tournament. So alliance selection is where the tournaments are won and lost. It's super important because you want to pick the right team to win the tournament, obviously. Um, and you don't really have that much time to make decisions. So during lunch, that's like the main time of when you actually talk to teams and being like, hey, we think we'd pair well with you because of X and Y. So during lunch, you have that nice hour, hour and a half gap period of where you're able to properly talk to teams and seeing who you might want to work with for the elimination tournament. And some stuff you should look for in a potential alliance partner is compatibility. So like how well the drivers work together or how well the drive coaches communicate with each other. Consistency is a super big one. You want to make sure your team is super consistent. You don't want to be with a team who scored super high only like 2 matches. You want to be with a team that's consistent and high scoring. And you also want to make sure that both drivers have a good synergy with each other. This is important because if they have a good like synergy with each other, you can just win. And just because the drivers have practiced together and stuff like that, you don't want to have an alliance partner where they don't really know your strategy that well. It'll just make things really hard going into the elimination tournament, especially when you get like semifinals and finals. So you should always create the pick list as if you are the number 1 seed. So even if you're 4th and the number 1 seed, you know you're not going to alliance with them, always have them as first, just in case some weird stuff happens with the alliance selection. And you should always tweak your pick list based on trends. So like let's say the first seed picks the 3rd seed, and that was your first pick. You obviously can't pick them, so now you're gonna have to pick like the 5th seed or so on and so forth. So your scouter should always be the one going up for the alliance section. They should have a sheet of paper crossing off teams as they get picked, just so you know who you're gonna pick. And just be careful of last minute shows. Like maybe one team did super well their last 2 matches, and you're like, okay, let's pick them. But before those last 2 matches, they were just playing terribly and they didn't win at all. You just want to be aware of like some teams might perform better in some matches, but they're not actually as good as they seem. Just be aware of that when going into the alliance selection, making your own pick list. So even if you aren't ranked high enough, like if you're outside the top 16 and you're ranked like 12th, 14th, be sure to go talk to higher seeded teams. This is super important because you don't really know what those higher seeded teams are looking for and what they're thinking when they're going into the line selection. And you can always make a good case being like, hey, you're super good at offense, or we can play defense while you play offense. It might be like, okay, sure, we have seen you around. You are pretty good at defense. That would work. And be sure to be super cautious when you're declining at competitions. Only decline if you know you can do better. So like, let's say, for example, you're the 5th seed and the 2nd seed picks you. They're not that good. They're a push bot. They're like, hey, we want to invite you. You should only decline if you know that the seeds from 6 to so on are significantly better than that 2nd seed. And you should only decline if you know you can do better than what you're getting picked by. And you should take riskier picks if you know you're outgunned. So like, let's say, for example, you're like the 16th seed and you're going to have to play against the 1st seed regardless. You need to pick a team that might have that inconsistency. So like one match, they're scoring like all the points possible, but in other matches, they're not doing that good. You might want to have to take that pick if you know you're really outgunned by a 1st seed, just because you might that team you pick might have a super good match, and then you guys just beat the 1st seed just because of that one really good match from the streaky team. So now we're going to look at this alliance selection scenario, and we're going to break down what's going on. So we have Team A, which is a true skill of 7 out of 10. Team B, true skill 8 out of 10. Team C, 4 out of 10. 4 out of 10, 5 out of 10, 9 out of 10, 9 out of 10. So as we can see, the seeds that are 6 and 7 are actually the best teams at this tournament just based off their true skill. So let's go ahead and look at this scenario. So for the 1st seeded alliance, the 1st seed, Team A, picked Team F. So Team A has a true skill of 7 out of 10, while Team F has a true skill of 9 out of 10. So that alliance combined together has a true skill of 16 out of 20. Let's see what else happens for this alliance selection. So the 2nd seeded alliance, true skill of 17 out of 20. So they're already better than that first seed just based off of Team B's pick of picking the 7th seed, which was probably the sleeper pick at this competition, and they probably got overlooked by the first seed just because of their seeding. Then we have the third seeded alliance. So this third seed didn't really make the best decision that they could have. They could have picked another team that was equally or just a little bit better than Team E, but that's okay. So when we look at these alliances in this alliance selection scenario, we can kind of tell that the best seeded team right now would have been the 2nd seed, just based off of their true skill ranking and how it is. So you always need to be consciously aware of the teams that you're picking in their true skill and like how they perform, because the first seed might be like, oh, the 2nd seed's the best team here, when it's actually the 7th seed, and the first seed just picks them because of where they're ranked. So you need to make sure your strategist knows like who the actual good teams are and not just take into account the ranking. So when you're making a pick list, a team's performance cannot be easily summarized by one rating. So you shouldn't just look at like the OPR of a team, because it might not be that good at offense, but then in defense, they're just insane and can shut down anyone. And there are also like so many factors that one must balance during the line selection. So like if the first seed picks a team, you need to understand that you can't pick them anymore, and so on. So having a list of teams that you want to pick as if you were the first seed is super important for the alliance selection, because you never know what they're thinking and what could happen. So just always keep those factors in mind when you're going through the alliance selection, and just know that a team's performance can't really be based off of one rating. You have to take into everything account their match schedule, how they've performed at previous competitions, and stuff like that. Because a really good team might have an impossible match schedule, but they're like the best team at the competition. Don't be like, oh, they're not good. Well, no, they just had a really hard match schedule, causing them to lose a bunch of matches. So just be sure that a team's true skill isn't like summarized by one specific rating. So now the competition's done. Things went pretty well for your team. So you're going to always want to reflect on what went right, what went wrong, what can we improve for future competitions, and the engineering design process just starts over, and you have to reflect on what you did to improve for next time. So keep that in mind after competitions. Don't just be like, oh, we did terrible, we can't improve, stuff like that. You can always improve, especially if you break down what happened specifically and what went wrong in the matches you lost and what went right in the matches you did win. And going back to scouting, if you go look at other teams' robots during the pit walk, you can kind of be like, okay, we want to implement this design into our robot because it worked for them very well and they won the tournament. So this is really when the engineering design process does start over, as after the competition, after you did the reflection of what happened. So just some simple driving advice for the competitions. When I was doing a bunch of driver practice for the 3 years that I drove my robot, I would always have the controller behind my back when I was getting used to new controls. It might sound weird, but it just builds your hand-eye coordination to where you shouldn't ever have to look at the controller when you're controlling a robot, because that just takes up time. If you're constantly going like this, you can't focus on what's happening around you or just stuff like that. In skills driving practice, always make sure you practice your skills driving. This is really important because you don't want to get to a competition and be like, this is my first time doing skills. What should I do? You want to make sure that you have a very clear and well-defined skills route, just because you could potentially qualify for states or worlds if your driver just drops a really high skill score. Another thing I would suggest is building a defense robot. This is just because you can get used to getting heavy defense played on you during a competition, which in some regions defense isn't as prevalent. So if you go to an event like Worlds and you're already super good at playing against defense, you're one step ahead above those teams who haven't really had any like rough defense played against them necessarily. And also getting used to higher drive RPMs is something that's super underrated. When we would do stuff in my previous team, I don't know what's going to be, our RPMs of our drive were always pretty high. So when we'd go to a slower one, I was already like kind of used to it, just because of me having experience of driving on like 480 RPM on 3.25-inch wheels. So if you're a newer driver, maybe ease into higher RPMs and then work your way down in the later half of the season, but that's at least what worked for us. So some other tournament advice Be flexible with the events, 'cause sometimes, like, you might get to a competition and fields might not be built, or the head ref isn't there, or just stuff like that. So just be flexible. Understand that not all competitions are set up perfectly or ran the same way. So just be understanding of school situations with fields and such. Be sure to have fun. This is the best part about Vex. You should always try to have fun with competitions, even if you're losing. Make the best of a situation. It's hard. I know losing sucks, but you can always look at the positives and be like, how can we improve from here to get to the next level to where we aren't losing anymore and we're actually winning. Another thing that's really fun is networking with other teams, because once you get to talk to those teams and become friends with them, they might share stuff with you. There's a lot of Discord groups, but be careful with some of them. You get involved in Discord communities. You can talk to teams on Discord and just stuff like that. And make sure you stay hydrated and stay fed. Don't do what happened to me at the first competition where you're super fatigued and tired. Drink a lot of water because you're doing a lot of walking back and forth and you need energy. So make sure you eat food and have a team brand. Go to a competition. If you're like the jesters, wear like fun outfits that are related to that or just stuff like that. Have fun at competitions, basically. Yeah.
All right, welcome back from our lunch break. So right now we're going to be going into our robot building tips. So you can build a robot that is as fine as that one that you see on your screen right there, the original Vex Clawbot. So I'm one of your presenters, Benji Miller, along with.
Hi, I'm Grant Kobus.
So yeah, we'll move on to the next slide. So our agenda here, we're going to talk about robot rules. We're going to talk about basic design and principles for design. We're going to talk about designing for controllability, and then finally, we're going to go into a section tailored into tips for VRC. We have spin up there, so I did not update that, but it's over under. I promise. I did update those slides, not that one.
All right, so who am I? My name is Grant. I've been in Vex for 8 years as a competitor, and now this is actually my 10th year for 2 years as a mentor. So I did 3 years on Team 8926 in South Carolina. We won state all 3 years. And then started a Vex U team, Why Not, the University of Tennessee in Knoxville. And in our final year that I was the team captain, we won both Worlds and the tournament championship, which was pretty cool, I would say. And then now I'm a mentor for the Why Not Alliance organization, which is a organization of multiple different teams from all over the U.S. competing to hopefully win Worlds again.
And who am I? I'm the guy posing with that big stuffed shark right there. I'm Benji Miller. I did 4 years of VRC, Team 127, and then I won 2 Arizona VRC state championships as tournament champion. And then my senior year, I got my team got third in our division at Worlds in 2018. And so now I do a number of things like this workshop. I MC, referee, judge, coach a team. And I have a master's degree in mechanical engineering, so that's how I'm currently employed. So, Grant, you want to start with the robot rules for VRC?
Yeah, let's get into rules. All right. So, first rule, have to use V5 components. It's really the only option. There's a few other little things that you can use, but you pretty much have to use stuff, especially electronics, that are V5. There's a size restriction in Vex. You have an 18 by 18 by 18 inch cube that you're allowed to use. You have to start in that size. There is some expansion allowed in this game in pretty much every orientation, which is cool. Some years that's not allowed, but you have to start within that size restriction. There you go. Yep, mechanics plan vertically. Have to use the V5 electronic system, which is the brain, up to 8 11-watt motors. This year, actually, we're getting into 5.5 watt motors, which are new. Those only come in, I believe, 200 RPM, so they're a little different than the regular motors, but we're now limited to an 88 watt system instead of a 811 motor watt system. Have to use a battery, and you have to use a radio, and they all have to be purchased off the Vex website.
18 by 18. I wonder where I've heard that one before. So we're going to start off with the rules for pneumatics. We have a couple slides on this. So this one is showing the old pneumatic system. They did recently release a new pneumatic system. So we'll get into that as well. But first of all, you're allowed up to 2 total pneumatic reservoirs, otherwise known as air tanks. And then you're allowed 100 psi of pressure. So please don't try to break that rule, because with the new air gauge, with the V5 system, if you're using that, you'll probably get caught right away. And as many cylinders as you want. They must match the Vex part number. And then we do, like I said, on the next slide, we're going to get into the new pneumatic parts that will show the different cylinders you can use. And then there's no motor penalty for using pneumatics. So if you can use them, if you can get your hands on them, as Grant might say, why not? So we're going to get into the pneumatics. Very punny. So they should be interchangeable with the old pneumatic system. Air is air. You see I have that nice O'Hare air right there because we're using the same diameter. And then also we have the different stroke length of cylinders. And so you might be thinking, what's the difference? So first of all, obviously, if it's smaller, you can fit it more easily somewhere. But that's not the only difference, because if you think about it, the total stroke distance is going to be a little bit different. So whereas before, if you wanted a shorter stroke, you might just stop it earlier. Now you can use a smaller cylinder. You can fit that in where you want. And yeah, instead of messing with basically the stroke length and the effective motion you can get out of it with just kind of a gear ratio or some leverage, you can actually just use different cylinders. And of course, if you use a smaller cylinder, it's going to use less air. So if you don't need that full stroke, you can probably just get away with using that smaller cylinder. And like we mentioned, the PSI is limited, so you're going to run out of that a little slower.
All right, so another fun rule you get to do is we get plastic. So plastic is any non-shatterable plastic, can be used to make different components of your robot. This allows for a lot more creativity, I think, in Vex, as the normal Vex system is designed off of these little half increment metal pieces. But instead, now with this, you can do a lot more custom stuff for your robot. However, you are limited to a single sheet of a 12 by 24 inch, which is about a 1/16 of an inch thick sheet. Doesn't matter what color it is. It can be like a tinted color, it can be clear, it doesn't really matter. As long as it's a non-shattering plastic. The rulebook actually specifies the types of plastic, but it's pretty much non-shattering. As you can see in these images, you can do a lot of cool stuff for this. So you can make these little hooks that this team once did for the tower takeover year. We have a ball launcher for on a catapult for what year was it?
I don't know. I can't bail you out there, but you could use it this year.
Yeah, you could use it this year. That was the flag gear. I just can't remember what it's called.
Turning point.
Turning point. Yes,
There's
turning point.
lots
There
of
we go.
keywords and then points.
Turning point and tipping point as well.
Turning point and tipping point. And did they go back to back on that?
No,
there was
like
1
a
year of gap.
separation. And
but
then,
still.
so another thing was this other picture is actually creating an entire structure piece for a reversible 4-bar, and then the actual single bar, all out of plastic, which was really cool. That was from Team 6007X, which I think now runs a really cool company. Pretty smart people. So other robot rules that you get to do, you can use anti-slip mat. The Vex website has this, but you can use other types of anti-slip mat. That's okay. In this picture, it's red. It has now been specified that you have to use black. That didn't used to be written that way. You can use 4-inch and 11-inch zip ties. The width does matter. That's important. You can get called out on that. And then the only types of rubber bands you are legally allowed to use are 64, 32, and 117B rubber bands. I personally prefer 64s over everything else, but I know the new 117Bs that Vex sells are actually quite nice and pretty elastic.
All right, so we're going to talk briefly about, well, maybe not that briefly, I guess, about gear ratios and sprocket ratios. It works on the similar concept. So just to clarify, a gear is what you see on that screen here where you have the interlocking teeth. Don't try to do that with a sprocket. It's not going to work very well for you. So the sprocket will be, you're going to want to use that with chain. And then, so what's the difference between chains and sprockets? Well, first of all, I'm sorry, gears and sprockets. So the gear, obviously, you have to be right up next to each other versus chain and sprocket. You can transfer that power over a longer distance. And then also the chain and sprocket, both the driving and the driven end will be going in the same direction versus the gears where they're going to be going in opposite directions. But then the principle of ratio is going to work out the same. So you see on that top left image, you see motor and then moving part, or you could also look at that as driving and driven. So there's a 60-tooth gear there that's driving with that motor, and a 36-tooth gear that is driven. So gear ratio, we're using this convention where it's driven over driving, 36 teeth over 60 teeth. It's a 3 to 5 gear ratio. What does that mean? So that means that this driven gear is actually going to do 5 revolutions for every 3 revolutions that this driving gear is going to do with that motor. And what does that mean for your building of these robots? Well, first of all, if you wanted to do something, maybe in a previous season you would do a flywheel, something like that, you would say do a 20-to-1 gear ratio, depending on whatever RPM cartridges you use on the motor, which essentially use the same principle. So you're gonna have a flywheel that's going super fast. Well, there's a drawback. So if you ever try to grab that flywheel, probably not while it's spinning, but say it stopped, you grab it, and then the motor tries to drive it, it's not going to be able to do it, because what you're giving up when you speed up like that is you're giving up torque. And the same thing works the other way. If you reverse those 60 and 36 tooth gears, and have the 36 tooth gear driving, the 60 tooth gear driven. The 60 tooth driven gear is going to be going slower by a factor of 3/5, but it's also going to have more torque, which means it's going to be essentially harder to stop intuitively. And then yeah, again, same thing with chain and sprocket. So if you notice that the drive in your robot is burning out all the time, you're getting pushed around on the field, well, maybe you made your drive too fast, or maybe that'll cause you to not accelerate as much because torque is what determines how fast you accelerate. So just because you have a really fast max speed in your drive, it doesn't mean you're necessarily going to hit that speed, because that's the free spinning speed. If you don't have enough torque, you're not going to be able to get to that. So that's an important thing to consider, especially with the small congested VEX field. It's 12 feet by 12 feet, and then it's basically cut in half this season. Plus, you have a bump to get over. So all in all, you're going to want a good measure of torque. Obviously, you're not going to want that to be so slow that everyone's running circles around you. So experiment and think about it, and bear that in mind when you're building a robot and you're burning out, that maybe we need more motors, or maybe this gear ratio is not working for us and we need to slow it down a little bit. All right, so we're going into structure. We're going to recommend that you use primarily aluminum. We'll say 99%. So if you notice there's one small piece and there's no way you can really brace it better, anything like that, and this one just keeps bending a little bit, something like that, okay, maybe you want to use steel there. But I'm talking about, you're using, say you have a lifting arm to lift yourself up for the elevation in this game, and there's just one really critical piece. Maybe that'll be steel. But yeah, if you're having robots ram into you and your robot is bending inward, maybe try to brace that another way as opposed to just saying, oh, we're going to make our whole drive base steel, because that's going to slow you down a lot. So again, if you're looking to start a team and you're ordering parts right now, I would say stay away from the steel. Just order all aluminum. Obviously, it's a little more expensive, so there's cost benefit. But for the purpose of being as competitive as possible, aluminum's your way to go. And then make sure you're keeping everything straight and making sure you're keeping it spaced properly. Because if things aren't aligning, say your drive isn't lining up, that is going to cause you a lot of issues with your drive burning out, making things not free spin as easily. Make sure you can free spin your wheels and your drive when the motor isn't attached. They should free spin easily, that kind of thing. And you notice there are square holes, and you're putting a round peg in a square hole, right? And there is a little bit of tolerance, there is a little bit of wiggle room, because you're relying on essentially your bolts to be tightened enough to have what we call in the industry preload on those fasteners. It basically sandwiches two pieces of metal together when you're putting a bolt between them. And if that preload is overcome, everything's going to shift slightly, and until it reaches the point where it's putting what we call shear stress on the bolt. Basically, it's pushing one part of the metal is pushing the bolt one way, one part's pushing it the other, and then that's gonna kind of, unless the nut comes off the bolt or something like that, that's gonna limit how far it can go. But by that point, it'll already be a little bit misaligned. So just bear that in mind, and then try to have mounting points or multiple connection points between two pieces of metal or two overall substructures as far away as possible. Because if you move, a fraction of an inch over here versus like moving a fraction of an inch relative to each other right here, that's going to be a lot more change in angle when they're close together. So try to space out your structural joints. And then, like I mentioned, Vex metal square holes create slop. Yep, and then a small low torque hand drill is going to speed up your assembly process. That'll allow you to iterate your robot design a lot more quickly. So if you're able to afford that, make sure that you consider that. But don't over torque it. You want to limit your torque when you do that, so you don't strip the head of the bolt, because that is very, very, very unpleasant. I think most teams that have been in robotics for a while have been there, and sometimes you're like, man, can I just cut my robot in half because I just need to get this bolt off? And then we'll speak to using the proper hardware, talking about nuts and bolts. You see that black bolt on the top and then two nuts right there. Nylock or Kep's nut? It's an age-old question in Vex. So we're going to recommend that you use Kep's nuts sparingly, and we're going to use them in combination with Nylocks. So there's a bit of a tendency with Vex teams that they say, oh, you know what? We'll just use Kep's nuts. We'll put on Nylox later. And later comes and you haven't done it yet, and part of your robot falls off in the middle of the match. So probably if you think you're gonna maybe be using that part later, I would just tighten it down with a Nylock. But definitely, if it's gonna be your competition robot, I would say all Nylocks. Kep's nut is only like, oh, I'm gonna throw this thing on real quick just to test it. And this isn't gonna be the final form or anything like that. But so overall, we're just like with aluminum and steel. Nylock is the aluminum of this debate. And then
Here, let's go back for a little bit. So
Okay.
another thing about bolts is we're gonna try to, if you're gonna use Nylox, please make sure that the bolt is actually long enough to get into the nylon portion of the bolt. I've seen this actually quite frequently, where teams will use a bolt that's too short or sometimes even too long. Too long is not a huge problem, other than it may stop you from building in other areas later down the line, and then you'll have to replace it with a shorter bolt. So just always try to measure what size bolt you actually need, as Vex makes tons of different types of bolts, and there's a tons of different options. And you don't want to be putting extra weight on your robot that you don't need, but you also don't want to be putting a bolt on there that's not gonna do anything when it gets to the actual locking portion of the nut, and then your robot just falls apart. So be very careful about your bolt lengths.
Yeah, exactly. So you see in that picture of the Nylock right there, you can see the white nylon portion at the top, and that's what Grant's talking about. So make sure the bolt gets to there because that's what provides your locking feature. All right, great point, Grant. And then I'll hand it over to Grant for our section on motion.
All right, so we got a lot to talk about in motion, but just to get started, so drive shafts, they're these little square shafts that you're going to have that fit into almost all the Vex products pretty nicely, honestly. But there's two types. There's the regular drive shaft, which is now called low strength, and there's the high strength. The high strength ones are pretty beefy. They're quite strong, but they're not very easy to use on most of the robot. You normally have to actually drill a hole in your C channels in order to use them, which is kind of pain in the butt. But in some cases, you do need them. But most of the time, you're going to be using a regular drive shaft or a low strength drive shaft. And these all drive shafts are going to need bearings. So you see on the bottom of here, if you're a new team, please use bearings. If your robot is making clicking noises or crunching sounds, please check your bearings. Bearings are very important to motion, as square hole does not make good turny thing. You need round hole make good turn. So high strength shafts, right? Not a huge deal this season. They can make stuff more robust, but they can honestly be used better in a lot of like actual structure ways than they can be used in rotary ways. Check for friction. So what I like to do is when I put my robot together, I like to spin all the wheels freely without the motors connected to see if one spins, for 6 seconds and this other one spins for 2 seconds. Well, the one that spins for 2 seconds might have unnecessary friction on it that is not gonna be good for the robot. So we want to make sure all of our drive shafts are spinning the same way, so that when we put our robot on the ground and we make it go forward for the first time, it doesn't actually go kind of left. So always check for your friction and your alignment. Please use the bearings. Bearings are quite important. Try to use the 2 support rule of thumb. That means try to have 2 bearings, one bearing on one side, one on the other. For these types of bearings that they're using, you have 3 holes, as you can see. You can use them where, like, on the 3 holes, you use like the first hole or the third hole to actually do the shaft portion of the bearing, while the other 2 are holding it in place. I personally would prefer that you use the center hole for most things. You don't have to do that, but normally it supports it a lot better and has a less tendency to shift, especially in drivetrains. So just be cautious about that. You can see in this picture here with actually the motor goes to a sprocket that has a chain on it, but you can see in the center, there's the bearing. There's also probably another bearing you can't see that's inside of the C channel, but keep in mind, bearing's quite important. I can't stress that enough. Reduce the number of external gears and sprockets when possible. So I did this once. I built a robot that had a chain of chain and sprockets of, I think, 9 different transfers of motion, which introduces what we call slop. So all this stuff fits together pretty well, but not perfectly. In order to make it fit together easily, to make this system, Vex has made it so there's a little bit of tolerance in everything. So the more gears you stack on top of each other, the more tolerance you're going to end up having. And I got it to the point where on my robot, I could spin the wheel almost a half turn either direction before the motor would actually get engaged, which is awful. Don't want to do that. So just try to think about ways that you can reduce external gears and try to use the internal gears on the motors when possible. But obviously that's not always the case, and you can't always do that. But try to generally use as little external gears as possible. So now we're going to get into different types of systems. So first, I've got a drive. I don't know why it's popping up like this. But so basic VRC drives, there's 4 main ones: the tank drive, the H drive, the mechanism drive, and the X drive. Most teams are honestly going to use the tank drive. The H drive is basically a little bit of an expansion on that, where we get a ability to strafe. So with an Omni wheel, that allows for you to turn really easily on the map, but also you can slide sideways if you have a force that pushes you sideways. So on this H drive, you can see there's, instead of 4 wheels, there's a 5th wheel in the center, and that 5th wheel actually pushes you side to side, which is pretty cool. Mechanism drive and the X drive are also capable of strafing. So actually the tank drive is the only one that can't. And in some cases that can be really helpful. In this case, maybe not. Depends on the game. In this game, our field is relatively compact, so I would like to think that strafing can be useful, but also there's going to be a lot of fighting in this game. So once again, the tank drive may reign supreme, as it normally always does.
Yeah, one thing, we're going to get to game-specific stuff later, but one thing I want to mention while we're on these drive slides, tank drive, it's the old reliable. Most world champions, I think it's fair to say, have a tank drive. So definitely not going wrong with that, especially this season with traversing that bump, maybe pushing back and forth in those little lower area or those overhang areas where you got to go under that bar. And then if you have that H drive, that center wheel is going to get caught as you try to go over the bump if that's part of your strategy, which I would recommend. And then X drive, H drive, or mechanism drive, they're going to have issues getting over that bump as well. So you definitely consider that, definitely test that out. And then also remember when you're testing that you're not just going to have a drive. So if you're testing, hey, can we get over the bump with this X drive? Put like a 10, 15 pound weight on it. Make sure it can actually get over with that, and not just the weight of the drive, because the weight of the drive is probably like 2-3 pounds. It's not going to be the same as your whole robot once you build that up.
Especially once you make the robot taller and you add all this stuff to it, your robot may actually tip once you hit those bumps. Some teams are going for go over the bump. Some teams are trying not to go over the bump and actually limit themselves under that 12-inch bar that we can get into in a second. But just some general disadvantages and advantages. The tank drive is the simplest robot design. It's fast, it's simple, it's very easy to increment on motors, and it's relatively hard to play defense on because it's got all that torque from being the way it's built, direct force. The H drive can be pushed in all directions. I can't lock out a side to be pushed on like I could on a tank drive because I need to be able to strafe all directions. The mechanism drive is similar, where it has that ability to strafe, but it's harder to push because of the way that the rollers are tilted are actually at a 45-degree angle, which is actually pretty cool. But the problem is its strafing motion is not in sync with its forward motion. So let's say for programming, it's actually relatively complicated to program because let's say I want to go a foot forward. Well, I only need 100 ticks to do that, to go forward. But to go the same distance 1 foot to the left, I need 160 ticks. It's not always that way, and the friction, this is a very friction-based drive that changes per field. So they're very, in my opinion, quite difficult to program without external sensors that are designed to go in those directions. And then the X drive is pretty cool. It's actually the fastest because of the way that the wheels are set up. But by having that more speed, it actually loses a lot of torque, and it can be pushed very easily. This is the easiest drive by far to play defense against, but it does have the most unique way of driving. It can very easily move and strafe in all directions with relative ease, but because it's so maneuverable, it can also be pushed any direction. So those are the basic drives. Personally, my favorite and pretty much the only one I've ever used is the tank drive. I've built one of each for every competition I've built at least one in my career and been to an event with it, but I almost always default to the tank drive because I just think it's simple and easy to use. Now getting to lifts. In this year, it's not super important. You may be interested in lifts just generally because it's something cool to talk about. But for this year, we also have an elevation portion, which you may consider designing a simple lift to help you get lifted. So a 4-bar is the simplest one. It's 2 bars, and then that are on both sides. So you have 2 bars here, and then on the other side of the robot, you have another 2 bars. and you have a equal space of a bar between them. And when you go up and down, that bar on the end is going to stay parallel with the rest of the robot. It's pretty simple. It's very easy to use. You can tension it, but the motion is not linear. So it's going to go up and down, but the actual thing when it goes up is going to start moving in this way, right, towards the robot. A 6 bar has a little bit more reach. It can go a little higher, but it can cause it to tip if you go a little higher. It's basically the 4 bar, but just longer. So if you need a longer robot, 6 bar is pretty cool. Double reverse 4 bar is actually famous for coming from Vex, from the Vex competition, and now it's actually gotten into first a little bit as well. But double reverse 4 bar is basically just 2 4 bars, one that's going forward and one that's going backward. And if you use them together, you can actually cancel out that non-linear motion side to side. And so now, well, this one's expanding, the other one's expanding. It actually keeps that center bar just going up really tall. They're pretty cool. They're hard to build because you're having to have these two lifts basically stay together all the time. They need to be in sync with each other. There's a lot more moving parts because there's 2 of these things instead of 1 now happening. So they get more complicated. They have more time that you need to maintain them. But they're honestly pretty awesome. And then lastly is the scissors lift, relatively uncommon. I don't know where my text went. I tried to find it, but it's not here. But so advantages, it's pretty cool. It does move linearly. Disadvantages, they're huge. They're very clunky. They have a ton of moving parts. They're difficult to maintain, but they do look cool.
Yeah, lots of friction, but it looks cool.
Really cool.
So weigh it, but I don't know if this is the year for the scissor lift.
Probably not.
Probably not any of these lifts.
No.
But definitely not the scissor lift.
Yes. All right, so intakes. This is pretty cool. This is going to be pretty needed in this game. Very important to control wheels. So there's the Coulson wheel style intake, which we're going to go right on the slides from left to right. Coulson wheels are just, basically just squishy rubber wheels that we use to intake an object into the center of the robot. So we have 2 on each side, and then they suck the thing in the inside. Tank tread is actually all the way on the right. Tank treads just have some grip on them. Basically, they're just tank treads, but with rubber on them, and those spin to allow basically a similar concept of the wheel, but you can actually make it linear instead of just being a round object. And then lastly is rubber band intakes, which actually have proven so far to be pretty good in this season, which is basically 2 sprockets that you string rubber bands between. And so it's kind of like a combine looking thing. But when the ball touches it, or in this case, the tri-ball touches it, the rubber bands are going to deform around it, but still grip it. And by doing that, it gives it a lot more compliance than a lot of other of these intakes will, and you can make them super wide. So you can do a lot. You have a big reach area, and since we're only needing to control 1 ball at a time, you just have a super wide intake, grab one, and keep going.
Yeah, one thing I'm going to mention about those rubber band rollers is if you have collars holding those sprockets, they're being essentially pulled together by all these rubber bands. If you have collars on those axles, make sure you get them really, really tight. Probably not using the set screw. You can use like a full-size screw there to make sure you get that cranked down really well, or even just fill it with a bunch of spacers in between. So just total spam of spacers in between, and then unless the laws of physics stop working, those spacers aren't going to phase through each other and allow them to collapse. So just be careful about that one. That's just one note.
Yeah, this is definitely a harder one to build because you got to keep the rubber bands from collapsing on themselves. Another thing you can do is add standoffs between the 2 things. So the shaft in the middle obviously is still there, but you have standoffs that are keeping the 2 sprockets apart from each other before you put the rubber bands on it. Like you said, spacers. This might actually be something where high-strength shafts would be nice to use because their spacers are a little bit more hefty. But just be careful. There's a lot of YouTube videos on how to build rubber band intakes out there.
All right, so robot robustness. As they may tell you in the manual, VRC is an interactive game every season. So be prepared to take hits from the defense. This means, hey, think of how fast your awesome robot is. Another awesome robot's going to be going that same speed, and they're going to run into you. Be ready for that. So if you're cringing every time that your robot runs into a wall or a robot runs into your robot, you probably don't have confidence in your build quality. Either, I don't know, I guess maybe it's just a psychological thing, or maybe you need to improve your build quality a little bit, just to the point where you feel, okay, I'm comfortable with this. Okay, it's not BattleBots. I do BattleBots. It's not BattleBots, but you should be ready to take an impact from a 20-pound object going at, I don't know, 5 feet per second. And then make sure you have a firm grip on the game pieces. Well, this year is not really a year where you're going to be holding a lot of them, but make sure if you do take a hit, that one game object, if it flies out, that's not a big deal. Make sure it doesn't fly out and say get stuck somewhere in your robot that's critical and it's going to incapacitate one of your subsystems or something like that. Make sure you reinforce problem areas. We're going to get to that later, but if something goes wrong in practice, make sure you fix it. Don't just, and I don't mean, oh, we've repaired it on the spot. I mean, you fix the actual root cause of it, right? Make sure that whatever deformed, you didn't just replace it. You rebuild your robot so that it can't happen again. And then make sure you design with maintenance in mind and have parts ready. So, wow, this really complicated, cool gear system is awesome, but then when it takes you an hour to replace the motor or to replace any other critical part that could fail, that's not going to be really good in a competition, because you're going to have the queuers running up, chasing you and saying, hey, we need you to get ready for this match right now. And you're like, well, yeah, but I need to replace this motor on my drive, so that's kind of important. You don't want to be in that situation any more than you need to. And then we'll look at pneumatics for rotation. Is this going to play the video? Yes, it is. Oh, it's a little small. But the point there is, look at that. That's a pneumatic claw, but it's rotating. How is it doing that? So basically you just pull on something that's on a rotational joint, or push on something that's on a rotational joint, and it'll rotate. Crazy. And so it's kind of a similar concept to the gear ratio, where the farther away from the joint that you push something, the more torque you have, but the less speed it's going to move. And in this case, the less distance it's going to move, since your overall driving distance is limited, right? With a motor, you can continuously turn 6 times to get something to rotate once. But with the pneumatic, if you're only moving a set distance, kind of that ratio of the distance for those cylinders is going to determine how far that thing actually rotates. And then also bear in mind that the V5 kit now contains different cylinder lengths. So if you want something to move a shorter distance, it doesn't mean that you have to put it farther out and have it go slightly slower, although the pneumatics are still pretty darn fast, no matter what your ratio is. You could just use a shorter cylinder, or maybe you need to use a longer cylinder for this because you want something to move faster, but putting the driving point on that rotation closer to the rotational joint isn't going to work for you, because, I don't know, you require more torque. All right, so we're going to talk about one of the most important things. Actually, these are all pretty important, but one of the things that takes a decent team into being a really good or a great team, I'll put it that way. So if, I don't know, you think that maybe describes you, then definitely pay close attention for this. So we're going to talk about designing for controllability, because it's one thing to look at that robot that you saw online and say, yes, I'm going to build that, and you build one that's like, okay, you're not the original person who thought of all these things, so maybe it's 90% as good, and you're gonna make it even better. But if your robot's not controllable, then you're not gonna have very good results in the competition, right? And it's not just that your driver's bad. Maybe the driver needs the programmer to work with them and make things a little easier to control. So first of all, we'll talk about tolerating error. So the best robots are going to work under non-ideal scenarios. So if you're doing an initial test on your intake and you're saying, okay, I'm going to put this tri-ball perfectly in front of the robot, and we're just going to drive forward, and oh great, it picks it up. Okay, that's awesome. That's a great starting point. But what you're really going to want to look at for tolerating error is, how does it work if it's 3 inches to the left, 3 inches to the right? You don't want your driver to have to narrow in on 1 inch that they're looking across the field and they need to line it up within a 1 inch tolerance, right? You want them to be okay, I'm within 6 inches of my perfect location, for instance, and I'm able to pick up this tri ball, right? You don't want them to have to do surgery remotely from across the field. And so most field dimensions, by the way, and object placements have about a plus or minus 1 inch tolerance. Look for specifics in the game manual. But what that means is when the field gets reset, hey, this tri ball might be a little off, and you might be tempted to say to the referee, hey, can we move that a little over there? And they might say yes, or they might say no, it's within the field tolerance. And so you go, shoot, my autonomous routine isn't going to work anymore because I need that to be, placed exactly where it's supposed to be. Well, if you built your intake with a little bit more tolerance for error, then you'd still pick up that tri ball. Your autonomous would work perfectly. You'd get the Think Award. You qualify for Worlds. Okay, that's best case scenario. But anyway, so you want to give yourself as much margin for error, both for autonomous and for your driver's ability. So if you're saying it works as long as you're perfectly lined up or something like that, then okay, that's a good starting point, but make sure you improve from there, right? Because that's the sign of bad robot design if everything has to go perfectly for your robot to work. And so there's some mechanical ways to tolerate error. An active intake like those rubber band or wheel intakes that we talked about. So grabbing with a claw is going to be a lot harder because not only does your driver or your programming routine have to probably line up with more precision, they also have to introduce another element, which is timing. So a robot that's designed with a rubber band roller that's continuously running, it's going to drive forward, and as soon as it touches it, boom, it's going into the robot. That's going to have a much easier time than I have to drive forward. I have to make sure I grab it at the right moment. Otherwise, I'm going to bump into it and it's going to go rolling away and I've missed my opportunity and I'm chasing after this ball for 15 seconds, while my opponent just shoved like 5 or 6 under the goal. That's not where you want to be. And so active intakes and then large intake area, like I mentioned. And then another thing you could do is a passive guide. So maybe you can't get your whole roller intake to be a foot wide, but you have an 8-inch wide roller intake and you have 2 kind of angled sections that are 2 inches wide on either side of that roller intake. So that way, when you drive forward, it kind of pushes that tri ball right into your intake. And then make sure you test it out that it's not going to get jammed if it hits that corner because I've seen that with rubber band rollers. If the sprocket kind of hits, it'll get, instead of the rubber band surface, it's going to get stuck. But and then make sure you have physical limits. So if you need something to stop somewhere, say an arm, anything like that, maybe you have a roller mechanism that flips in, flips out. Make sure it has a mechanical stop where you want it to stop. If you never need it to go past a point, put a mechanical stop there. I don't care if it's programmed to move back and forth with a motor and you have a beautiful PID loop, just put a mechanical stop. And then make sure you use flexible parts as much as possible so that you can guide things into your robot as best as you can. So you need to have compliance basically so that everything doesn't have to line up perfectly. Here's an example. So what are some things, unfortunately we're not in person right now, so it's a little harder to pull the crowd, but what are some things you notice with this robot? Both where it's going to pick up this cap and then when it's going to put it on the post. Notice this is fully autonomous, right? So you notice it's an active intake. That's one thing I discussed. And it's got a physical guide when it's going to pick up that cap that sort of pushes it into that active intake. So you already don't have to worry about aligning perfectly. You already don't have to worry about timing. And then when it goes to put that cap on the post, what do you see on the back side of that robot with those big Vex logos on it, right? You see these little polycarbonate, I don't know what you call it, wings maybe, and it's going to guide the robot into lining up with that post because otherwise, look at that area of that cap where it kind of goes on top of the post in the middle. It's not really a very large area. So you want to do everything you can to make sure you build your robot so that it can line up with that as easily as possible without you having to do, precise surgery. And then we're going to design for controllability here. So do you want like this big 6-degree of freedom robotic arm on the right that you have to control all of these motors precisely to get the end effector on the end to go exactly where you want? No, you probably don't, right? You want to simplify your motion. And so when you're making the robots controllable, this depends on your team programming capabilities, but the mechanical features that we discussed, those are going to help you out as well. But keep things as simple as possible in your robot build, and that'll help out your programmer a lot. Your programmer doesn't have to be amazing for you to actually be consistent in your programming skills and your autonomous. if you just build things in a way that it makes it easy for the robot to pick things up without having all the precision. And then you notice here I have the 2 red boxes around there. That's a 2-stage intake. Not that you'd probably want a 2-stage intake this season if you're only getting one object. But that allows, for instance, in that season, Nothing But Net, you would be able to be continuously picking up more objects with that first stage of the intake, whereas the second intake stage is controlled separately. So when you're going to intake objects, you're not also running the top part of the intake, which is going to shoot them off into the flywheel. Stuff like that. And then, yeah, like I mentioned, multiple degree freedom robotic arms. Pretty odd this season, but you would want to consider things like how are you controlling your launcher, that kind of thing. Okay, so ease of control. I would recommend whatever direction you consider your driver, whoever considers to be the front of the robot, and you can change that. It's up to your programming, but I would recommend that you intake and score on the front side always. It's the most natural for the brain. And then I think the biggest time waster that we see inexperienced teams, it's like I mentioned, you're spending 15 seconds chasing that tri ball down around the field. It's kind of hard to watch sometimes, I'm not going to lie. So make sure you're working on acquiring those game pieces quickly. That's going to be one of the biggest determiners of how good your team is. So touch take intake mechanisms, that's usually an active one. Sometimes you can do that. You can still build in room for error with other intakes, with claws, that kind of thing. But as much as possible, you should be able to pick up game objects on accident. If there's a tri ball and you didn't see it, it should go into your robot and get taken in, right? It should be that easy. You just need to drive your robot to the right spot. And then have a large area as possible for collecting those game pieces. Automate systems as much as possible. We'll get into that. What some people call macros. Instead of saying, okay, I need to move this button to move this motor, this button, press this button to move this motor, do all these things in sequence. Hey, if you're doing the same thing in sequence, that sounds an awful lot like something a robot could be programmed to do, right? If you're trying to do the same thing over and over again, right? That's what we have code for. If you say, well, to score this ball, I just have to press these 3 buttons in rapid sequential order, and maybe there's like a timing element as well. Maybe you just make that one button that's a macro. And then most important tip, don't practice until you get it right. Practice until you can't get it wrong. What does this mean? Make sure you're aiming for 99% plus consistency in your practice, closer to 100% if it's anything that you're dealing with that could end your match. Like, oh, our robot tipped. Oh, that's fine. We'll just put it back up and keep practicing. No, you need to make sure if there's any way you can build your robot at all, change it around so that you can't tip. Any programming controls maybe you could do to prevent that. The last thing you want to do is tip at the beginning of your match, and then you're just sitting there having the worst Vex Robotics experience of your life as the match plays out around you and your partner gets 1v2'd hopelessly. And then the driver practice isn't just about the driver. So look for issues with the robot performance. And this is why driver practice is so important, because usually, say I'm shooting hoops, I'm practicing that. That's like working in your driver skill, right? But the nice thing about Vex is you can get so much better with practice, because it's what if, okay, I'm working on my skill and then someone's, augmenting my arm to, never get tired at the same time, right? Like you're working on improving in multiple different aspects. You can work on your programming, you can work on your driving, you can work on the build quality of your robot all at the same time. And things will never be nearly as clear to you as when you finally get to do some practice and you see how things work. And then, like I mentioned, if your robot messes up and breaks, if it tips, you don't get to fix that in the middle of a match. It's going to be a really uncomfortable minute and a half as you watch the match play out. So make sure you fix that in practice. I mean, I've been there. Things come up. They really do. That you've like, well, this never happened in practice. But if it does happen in practice, that's your opportunity. That's a good thing. And then here's what we were talking about with controllability earlier. This is an example of a macro in Tipping Point. We figured out the name of that game. Great job. And then, so they have a macro here. They shoot one high, boom, and then they angle their shooting puncher mechanism, whatever you want to call it, and then to shoot one low. So the driver is just demonstrating he's only pressed one button there, and then he's shooting both those balls at exactly where he wants. So basically, all he has to do is line up with 2 balls and then press a button, and the robot does the rest. That's so much faster, so much more consistent than the team who goes, okay, I have to press this button to fire, and then I press this button to angle the shooter, and I hope to get to the right angle, and then I press this button to intake, and then I press this button to shoot again. Like, that's going to take forever. It's probably not going to be as consistent.
Woohoo! It's game time, baby.
It's game time. Da-da-da-da, da-da-da-da. Okay. So VRC over under tips. I just wanted to start out with this quote: "Whatever you are, try to be a good one." Because maybe it's just because it's early in the season, but I really feel like there's a lot of different things that you could do this season. I want to speak to that a little bit, Grant. Or we'll get to that later. Any big ideas about? Okay, anyway.
We got that. We got that coming up.
We got
Don't
that
worry.
coming up. So there are a lot of interesting and good robot styles bouncing around. You can, throw balls in a number of ways. You can shoot balls across the field in a number of ways. You can say, I want to do a short robot that goes under, and it also can traverse this bump. Or you can say, I just need to traverse the bump, or I just need to go under. You know what I mean? And then you can say, okay, I want to hang high. I want to hang low because it's not worth hanging high. So anyway, there's a lot of different robot designs that are good, but get that practice in and make sure you really dial in your robot, whatever it is. So you don't need to chase whatever is the meta all the time. You can be one meta behind because maybe things go back and they say, okay, wait, this old meta was actually better.
Yeah, this is actually a really interesting game of having a lot of different things that are useful for the meta. Meta is, if you're unaware, basically what everybody wants to use, the thing that's most common. So first, let's get into drives. Back again to talk about more drives. So like I said earlier, I'm a big believer in the tank drive, and that is because this game is called over and under. Okay, we're gonna go over the goal and under the goal. As you know, on the end of the field, there's these little 12 or elevated by 12-inch poles. But then also in the center of the field, there's this, I think it's a 3-inch off the ground pole, something like that. I think it's 3 inches. So on my group of teams, we've had numerous designs. Some robots are designed to be as slim as possible. They not only go under the 12-inch side of the field, over the 3-inch bar in the center of the field, but they can also go under the actual goal itself. It's a cool option. One of the things you can do this year is de-score if there are 2 robots on your side of the field from the opponent, and you're on their side of the opponent, then you're allowed to de-score those balls, or the tri-balls. So when you're looking, it's not just the drive, but it's probably wise to be low enough to get under the bar. I would recommend trying to stay under that 12 inches. I know that's going to be sort of difficult, but I think generally with this year, since we're only dealing with 1 ball at a time, it's actually relatively doable. You just have to think about everything and not that normal 18 by 18, but how can I keep my robot short this year?
Yeah, and I think part of why there's a lot of, well, there is, and I think there's going to be for a while, a lot of diversity in the design, is because it's such an interactive game. I think it might come down to sort of a rock, paper, scissors of how do we react to our opponent's strategy, what type of robot is good against this type of robot. So, yeah, it's not like, it's in the zone where we're just stacking cones, right? And so what's the best way to stack cones? It's what's the best way to throw, when someone punches us this way, we punch back. So there's going to be a lot of variation in that.
Yeah. And so another thing we can look at is the Mall of America signature event has already happened, which includes a lot of teams from around the country. A few WNA teams as well attended. And it's basically the, biggest event we have early season. And I mean like super early, before school even started. We had this tournament at the very beginning of August. And we got to see a lot of teams that were getting bullied, that were taller robots that could only go under the bar, but they couldn't go over the regular, like in the middle bar. And because of that, all you had to do as their opponent was just go and block off the sides of the field. As soon as you did that, they could never get to the other side of the field to work with the tri-balls. So we're going to truly stress this. I think it's going to be important to not only be able to go under, but to be able to also go over in a controllable manner, because it's just going to be such a back and forth game of trying to, throw a robot all over the field. All right. So intakes. Intakes. There's a lot of different ways to do intakes. I know earlier we were talking about possibly using the rubber band roller style. It's been pretty good at being able to pick up stuff in front of you, especially in the match loading area if you need to pick something up away. But another cool one that a lot of teams have been utilizing is picking up the balls based on like the Coulson style where the balls are on the side. So this robot is actually a WNA robot from the Robot in 3 Days that we did. It's 4 teams actually it was about 7 teams that all came together that used to be on our alliance, and they all created their own robots, mixed the teams up. 4 different robots were built, 4 completely different styles. And this one was actually the best. This is the tournament winner that we had. This robot was built to pick up the balls in the center as quickly as possible from the front, and then in the back of the robot you can see the little U-shaped thing that actually threw the ball across the field. So not only could it take the intakes to push the ball under, but it could also throw the balls from the other side of the field. Since we're only allowed to use 1 ball, focus on that, right? We're not trying to pick up 4 balls at one time. We're designing our system to only control 1 ball. You're going to need an intake that flows. Not so much only with 1, but a grabber is more valid, though touch intake principle is still really strong. Just being able to get to a ball and grab it and get rid of it is going to be pretty helpful this year, especially since we're going to start seeing a lot of these balls get thrown all over the place. Although it's technically an intake, it seems that these hurting is going to be pretty cool. We had a few robots actually also in the WNA Robot in 3 Days and at the mall event that basically expand to get really big, and while they're not controlling the object by using a concave surface, they're using a flat surface and sort of herding them around. There's a very particular rule about that, so be very careful if you do design this type of system. You cannot have a concave system that hoards the balls in, but it can like kind of push them around, if that makes sense. You can use pneumatics to basically have like a flap on the entire side of your robot that just like folds out like this kind of deal. And those have been really successful at not only shoving in as many try balls in the last few seconds as possible, but also using them to try to pull balls out later in the match.
All right, so I'm going to talk a little bit about launchers. So when you're designing a launcher, you kind of want to think, well, what is my purpose, right? Am I trying to, if you do decide to do a launcher, because, okay, it's not a given that you do, but the primary purpose is to try to throw try balls to the other side of the field. But then secondarily, there are some teams that are trying to also put them into the goal. And so that's not going to be quite as consistent, although I think it is fairly consistent to have an accurate shot from set locations, say match loads, especially for programming skills or driver skills. I've seen that a lot. And so you're going to be punching them specifically right up against the goal, and then that can pair with some of that tri-ball herding that Grant talked about to shove them in. So I think that was one of the highest skill scores that I saw. Maybe still the highest. I'd have to check on that. It's still the highest. He knows which one I'm talking about. So basically you have to think, what is my objective? And when you're thinking, what is my objective? Well, you might think, how are people going to try to counter this, right? So if you're throwing, tossing, shooting, whatever you want to call it, with a really low trajectory, that might be very blockable. Versus if you do a really high shot, it'll be virtually impossible to block. So that's another thing to think about. And there's text backing me up. It's in print. You can't disagree with me now.
Blocking was a really big deal at the Mall of America event. A lot of robots weren't ready for that, and a lot of them got blocked by just simply having like a piece of plastic on the front of their robot.
Yeah, and that's
got other robots down.
Right, and that's something that a lot of people don't think about when they're designing their robot, because, I mean, I guess if you want to go for robot skills, you don't have to worry about what other people are going to do necessarily, but you need to think about how other robots are going to try to interact with your robot and counter the counter, basically. And then, in my opinion, the best kind of launcher, you could think of a lot of different types, but I think the best way to drive a launcher, at least, is with a slip gear. So you see that red gear, for instance. So that one has all of its teeth, but then the driving one is going to have some of its teeth shaved down. And think about what's going to happen as those two rotate together. When the driving gear gets to the point where it's shaved. The driven gear is going to be free to spring forward if it's rubber banded, and then the driving gear is going to keep rotating, and then the teeth are going to re-engage. It's going to pull it back. And basically, rotational motion is translated, or a continuous rotational motion is translated into pulling back, leaping forward, pulling back, leaping forward. So you could even do that linearly with rack and pinion. But I think rotational motion in Vex is usually my recommendation when you have a choice on that. Okay, and then obviously if there's another way to do a launch or anything like that, it's probably not going to make a big difference. I recommend motor power though, just because if you're using pneumatics for launching objects, which is one of the most frequent things you'll do in a match, you're going to run out of air pretty quickly, and you're going to have inconsistent launches. So here's an innovative idea I liked from Team 229, throwing tri-balls across the field and punching close to the goal. Let's see if we're able to play. It says unable to play. With the same launcher.
This is from the 229 Ace reveal video.
Yeah, let's try to see if we can pull that up on YouTube, because I just wanted to share this one. Sorry about that. It's kind of interesting, the other video. There was another video that popped up, right? Yeah, but this one didn't want to work. So we don't want to see Alex browser history, I guess. I'm just kidding. I'm just teasing him. But anyway, so we're gonna stay on this presentation. But basically, I'll just describe to you what they had. So they had basically let me. Okay, here we go. Backward positioning. So over here, where I'm holding this clicker, down here they had the part that the robot would intake into with a rubber band roller, and it would throw from there. And then down here, closer to my elbow, where my arm's rotating, it had basically a standoff that would punch the ball. So they kind of got a... Oh, we got Carter on screen. Okay, that's our... Okay, technical difficulties. But anyway, so basically they're using the same mechanism for two different purposes, just with a little standoff. They had a spot where they could match load the tri-balls, and then when they match loaded them, just punch them with a little standoff when that slip gear launcher came around. So yeah, that's a way that you can use the same mechanism to do two different kind of tasks. And then with the punching close to the goal, they were able to really dial in the location. My clicker's not working now. Oh wait, there it is. We're good. Vex over under. We're going to talk about elevation mechanisms. I feel like this is one where there's a lot of still open room for creativity, just because it's kind of a hard task, and it hasn't been as well developed as some of the others. I think a lot of people are looking at the points and deciding not necessarily is worthwhile. But if you're going to go really high, you probably want to use a PTO, power takeoff mechanism. Just because to get to that high, you'll probably need motor power. I don't see how you'd get really high with pneumatics. But you're not going to want to have motor power, like your limited allotment of motors dedicated to that for the whole time. But you're not going to want to launch tri-balls at the same time that you're going up to elevate. So you could easily have a power takeoff from your launcher, for instance. But you probably still would want the drive to align.
Over here, we actually have two very simple options that get just basic points. On the one that says credit WNAR 3D, we have a very simple, quite literally a C channel that just grabs on and holds onto the side. Because our robots are now designed right to drive over the pole, it drives onto the pole and then sort of throws itself and just rests with that little side piece there on the side of the pole. And then the other style we have right next to it is one that's actually using motor power to kind of like use a pull-up bar and crunch itself up onto that bar. Both not really that high. I think they're A and B style hangs. They're not that tall, but pretty simple options. Highly recommend the one that's on the lower left. Pretty simple. As long as you can get up on the pole, super easy to do. A more complicated one here we have a video of, I think. I don't know if it'll play.
Yeah, so this wasn't a whole hang mechanism, but it was just kind of showing you how you could passively grab to that pole. So we'll leave the rest of the lift up to you, I guess. But it kind of just, if you put the weight where that person's hand was, and you pull down, it's gonna cause the entire subassembly there to twist, and it's gonna bind up on that pole. Because notice you can't grab onto that yellow cap. And then over under other utility, this is kind of what we were talking about earlier. You need to know what other people are going to throw at you. Throw something at them, they'll throw something back at you. And so you have access to pneumatics for no cost. Well, it's going to cost you, but it's not going to cost you in terms of a motor penalty or anything like that. And so, I don't know, maybe you want a pneumatic part that's going to throw up this blocking shield that's going to block someone else. That could be really effective. If you have wings that expand out to herd balls, or maybe they have two pistons so they can expand, a different distance to maybe just grab some tri balls out. Use your creativity, obviously. Power takeoff, that kind of thing. There's lots of ways to use pneumatics that are, I can't tell you right now because there's a lot of people out there who are gonna do a lot of thinking about this. It's August right now, but just be aware, be ready for what people might throw at you, and then be ready to throw it back at them. Okay, I guess, do we have any questions online?
I have a shameless plug. So with my organization, WNA, we actually did, like I said, the robot in 3 days. Very cool videos those teams actually put together. We not only have a reveal of all 4 robots, but an individual explanation explaining how all 4 robots were built, what the systems and the thoughts were behind those robots, as well as a full 34-minute documentary over the 3 days to explain, what the teams were thinking of while they were designing the robots. Highly recommend at least to watch. I don't know if you have one practice, just sit down and, go through YouTube. There's a lot of cool stuff that a lot of teams are posting, like 229V Ace, the robot we were trying to show you a second ago. Also really cool robot. There's a lot of good early season reveals out there. Keyword, early season reveal, Vex. I would look up. It's very helpful to find stuff early season. I know when I first started in Vex, that was something I was always super interested in, was finding those kind of robots those people would post. And then later in my career, I was like, oh, okay, maybe I'll try to make one of these and see if it'll help anybody. And actually found meta. So I would recommend it. I would look at some stuff, try to find early season reveals. Really helpful.
All right, cool. So no questions online? Okay, I think, is this our last in the second room? The second room, this is the final presentation. So we have another presentation in our primary room. That's going to be at 2:45. So yeah, stick around for that. And that's going to be all for our build tips. Thanks for listening. Thanks for tuning in.